Timekeeping in space. Why clocks on Earth won't work on the moon and Mars. I'm Hewie Poplock. I'm going to be talking about a surprising challenge for future space missions, keeping track of time. In places like the moon and Mars, we'll see why our familiar Earth clocks won't work so well off of Earth and what NASA, SpaceX, and others are doing to fix that. By the end, you'll understand why something as ordinary as a clock becomes extraordinary when we venture into space. Our clocks all agree on time because we have standards, like Coordinated Universal Time, or UTC, based on precise atomic clocks, clocks that measure time by the vibration of atoms. Imagine if everyone had different times on their watches. Scheduling a call or a meeting would be chaotic. In fact, imagine if the world wasn't syncing their clocks to the same time. How disruptive that might be. In space missions, timing is everything. Spacecraft need to communicate with Earth at scheduled moments. Astronauts perform tasks according to a strict timeline, and navigation systems like GPS require precise time to pinpoint locations. If clocks aren't aligned, a message sent from Earth might arrive too early or too late, or a rover might think it's in a slightly different place. For NASA and SpaceX, which planned complex missions to the moon and Mars, having reliable timekeeping is as crucial and critical as fuel and oxygen. Spacecraft and mission control must share timestamps. If time is off, data transfers might fail or commands could execute at the wrong moment. Navigation and landing, precise clocks let us calculate spacecraft's position. A tiny clock error can make lander miss its mark by dozens of meters. Astronauts on the moon or Mars need consistent day-night cycle for work and sleep. Timekeeping helps everyone agree on schedules, which is vital for safety and coordination. In short, without good timekeeping, space missions could become confusing and even dangerous, which is why this topic has NASA and SpaceX and other agencies paying close attention. Earth versus Moon, a time dilemma. On the moon, time runs slightly faster than on Earth because of weaker gravity, as explained by Einstein's relativity. A clock on the moon gains about 56 microseconds per day compared to the one on Earth. That might sound tiny, but over time it adds up, enough to throw off a spacecraft's position by the length of 168 football fields in just one day. Also, clocks on the moon's surface and in lunar orbit don't stay perfectly in sync because of different gravity and motion. If we can't simply use Earth's clock on the moon without adjustments. For missions like NASA's Artemis or SpaceX's landers, precise timekeeping is critical for safe communication and navigation. That's why the moon will need its own time system. Relying on Earth's time would lead to confusion and errors. Mars time, another planet, another clock. Mars brings a new time challenge. Its weaker gravity means clocks tick slightly faster than on Earth. But the bigger issue is that a Mars day, or sol, lasts 24 hours and 39 minutes, about 40 minutes longer than an Earth day. If astronauts used Earth clocks, noon would slowly drift into the night. NASA already adjusts rover schedules to match Mars time. Future Mars settlers will need clocks and calendars designed for Mars' longer day and year. Like the moon, Mars clocks will also drift compared to Earth's clocks if we don't adjust for relativity. To keep missions safe and coordinated, NASA and SpaceX will need a Martian time system that works locally and stays synced with Earth. How it affect missions, NASA and SpaceX. Why does keeping time matter for NASA, SpaceX, and others? Well, here's why. 1. Navigation. Spacecraft navigation depends on accurate timing. If the moon or Mars clocks are off, a lander like SpaceX's Starship could miss its landing spot by kilometers. Without shared time system, data transfers and communications won't stay in sync. Communication. Mars missions will send lots of data back to Earth. If clocks aren't aligned, important info like light support updates could be delayed or misread. Staying synchronized is crucial for safety. And then safety? Imagine astronauts or mission control teams working on different clocks. One team's 3-2-1 fire could be another's already fired or not yet. Even a small time drifts could lead to mistakes or accidents. International missions. Many nations and companies will operate together on the moon and Mars. If everyone uses their own time system, teamwork and emergencies would be harder to manage. The International Space Station solved this by using one global time, UTC. We'll need a similar standard for future space missions. In short, without accurate shared timekeeping, space missions could face navigation errors, communication breakdowns, and safety risks. NASA and SpaceX must solve this challenge to ensure their ambitious plans to succeed. Current approaches, learning from Earth and ISS. Right now, astronauts on ISS use Coordinated Universal Time, or UTC, so everyone works from the same clock, no matter what their country. This works for ISS, but won't work on the moon due to different gravity and time flow. Space agencies have agreed we need a common lunar time. NASA is leading efforts to create Coordinated Lunar Time, or LTC, by 2026, so all moon missions can sync together. Scientists are also designing lunar clocks that adjust for the Mars gravity to stay accurate. Solutions on the horizon, a lunar time zone. Key solutions being developed. One master lunar clock, a shared moon time for all missions. Atomic clocks on the moon. Super precise clocks on the surface and orbit to broadcast time like lunar GPS. Synced but adjusted to Earth. Lunar time will stay linked to Earth but account for gravity differences. NASA's Artemis program is driving this work to make sure future astronauts have reliable time for navigation, communication, and safety. Looking ahead, Martian time and beyond. The moon system will pave the way for Mars time. One day, we may have coordinated Mars time, or CMT, using satellites around Mars to keep colonies and missions in sync with Earth. A shared time standard is key for safe operations, communication, and planning across planets. Implications for future and conclusion. Creating reliable time systems in space will make missions safer and more precise, allow global cooperation, bring tech improvements back to Earth, support daily life for people living off Earth. As NASA and SpaceX send astronauts to the moon and Mars, solving timekeeping ensures we're ready for a future beyond Earth, where even time must be reinvented. Timekeeping in space, keeping time on the moon and Mars. Why a moon clock and a Mars clock may be needed. NASA and SpaceX's surprising challenge with time. I'm Hewie Poplock.